All right, in this video we're going to go through the solutions of the second applications test. So this one I did purposely make harder because you do need to be exposed to questions that aren't routine. So you need to think, all right, how would I answer this and answer it? So if you're constantly exposed to questions you can do, you're not going to learn how to answer questions that are unfamiliar. So I tried just to think of some that were unfamiliar. Okay, so Lucy kicks a soccer ball off the ground and she scores a goal. The path that the ball travels can be modelled by the equation h equals d minus d squared over 12, where h is the height of the ball in metres and d is the distance the ball travelled in the air in metres. So if you think just quickly about kicking a ball, there's a ball, Lucy kicks it, and then it lands. So if we were to put this on a set of axes, she starts here at 0 and ends at 12. So that's your distance, and that's the height of the ball. Now, the formula has been given to you. So question A, show that the distance the ball travelled in the air is h metres. So you basically will say, well, let h equal 0, and then you're basically finding your x-intercepts or your d-intercepts. So we have d minus d squared on 12 equals 0, and then just take out d as a common factor, and I'm just realising I'm probably not going to have enough room to do this. So it's 1 over minus d on 12. Divide both sides by d, so then you're basically, and I'll just have to do it up here, left with what's in the bracket. So 1 minus d over 12 equals 0. And, so that means that equals 0 or d equals 0. So when we solve this, we get d equals 12. So basically, you just had to show these x-intercepts, and then you can say something like the distance between the two x-intercepts is 12. Or you could say 12 minus 0 equals 12, therefore distance equals 12 metres. Something along those lines. So you basically just had to find those x-intercepts. Show that the maximum height the ball reached is 6 metres. Now I had to get you to change this to 3. Okay, so remember your maximum height, because here at your turning point, which is halfway between your two x-intercepts, 0 and 12, which we did before. So halfway point is at d equals 6. So all we have to do is work out what that is, what h is when d equals 6. So 6 minus 36 on 12, and that gives you 6 minus 3, h equals 3. Okay, so it happens at 6 metres, but the height is actually 3. Okay, and I might just quickly change that now before I save it. Okay, sketch the graph of h on the axis below, clearly labelling the intercepts and the turning point. So remember, you can put this on your calculator. So let's put this on our calculator quickly. So, whoops, where are we? Graph. Now remember, in your calculator, you're doing things in terms of h and d, not h and d, x and y. So the f1 of x is your y. So we're now just going to have x minus x squared on 12. Okay, and there it is. You can't see the axes, so remember, look at what it says on the screen, on the piece of paper. We don't want to do that. So let's just make our x a bit longer. So you can see you got an x-intercept there at 0 and 1 at 12, and your turning point. So let's just say, move that out of the way. So let's just say you couldn't do anything previously. You should know your maximum. There at 6.3, and your 0. You can see that one is already at 0, so the other one is at 12. So when you're sketching it, you've got x-intercept or d-intercept at 0, and then 12, and then your other one is halfway, it's 6, 3. So, oops, it's a bit wonky. So there's the ball, okay, and let's just label the intercepts 0 and 12. Now you could keep going, but try to always think of the context of the problem, even though I haven't really taught you the domain and range. You should know that if you're cooking a ball, the height of your ball cannot go into the ground. Okay, let's move on. The goalkeeper is standing 9 meters away from Lucy. The goalkeeper can jump 2 meters. By how many centimeters will the goalkeeper miss reaching the ball? Okay, let's just go back to the graph here. I'm just going to have to redraw again. So there's start point, end point. Oh, that is terrible. Okay, now your goalkeeper is standing at 9 meters. Okay, so here's your goalkeeper. And if you wanted to, just think about, well, there he is, or she. And the goalkeeper can only reach a height of 2 meters. So basically, you've got to find this point here. Now, I'm just going to change back to blue. So basically, you're saying, well, h equals 2. So I have to find, oh, sorry, not h equals 2. D equals 9, where the goalkeeper is. So your h is equal to 9 minus 9 squared on 12. 9 minus 9 squared is 81. And I've done this one before, and was it 2.25? I think it was 2.25. Let's just quickly do that on the calculator. And you could also use solve on your calculator if you wanted to. So I'm just going to go over the top of this, or underneath it. So 9 minus 81 on 12. And you can see that's 2.25. Okay, so if it's 2.25, how much does the goalkeeper miss it by? So it misses it by 25 centimetres. Now the next question, and I'm going to keep that up because we need that graph. What distances would the goalkeeper have to stand in order to stop the ball from going in the goal? So your goalkeeper, so the goalkeeper, let's just change the colour. I've already drawn it, sorry. Oh no, I'll keep it yellow. So the goalkeeper is here, can reach 2. So basically, sorry, you can hear my dog. So basically, we got to find these 2 points that I actually circled before. So at this point here, h equals, oh, don't do that in yellow. Let's do it in blue. So when h equals 2, basically. Now, when you think of soccer, you can't, I don't know how far out the goalie is, but I would accept both of them. Sorry, I'm getting distracted. My dog's barking. Okay, get the calculator up. You can do this by hand, but I would be happy for you just to do it on your calculator. So it's just a plain solve. We want h to equal 2. Can you see that under there? Maybe I need to move this. Okay, so 2 equals, and you can use d minus d squared. I don't know whether you can hear her. Okay, sorry, I just pressed pause to turn my doggy off. Okay, so there's your exact answer. So to get that as an approximate, you can just press, and I'll just have to move this because you probably can't see it. Control Enter. Okay, so you can see it is at 2.53 and 2.54, 9.46. Okay, so I might write that before I forget it. So, oops. D equals, what was it? D equals 2.54. And 0.46, was that right? Let's just double check. Yep. So basically, if we think of this goalkeeper, let me just use a different colour. So this goalkeeper can get the ball from any point below this line, or this point. So the goalkeeper can reach it here and can reach it here. Okay, so anything between this. So basically we can say when D is less than or equal to 2.54, okay, so that's this value here, or when D is greater than or equal to 9.46. Okay, so at either point here. Now that was quite a tricky question, but something that you will do in methods basically. So understanding points of intersection like that, okay, and what they mean in the context of the problem. All right, let's move on because I don't want this to be a long video. Question 2. Peter is designing a garden feature made out of wire and wood. The garden feature is split into 2 sections. The wooden rectangular section, length equals x, so we can see that over here, and height is x plus 1. The wire arched section, the length is x and the height is 0.72 as shown in this diagram. Okay, so show that the perimeter of the rectangle is given by p equals 4x plus 2. So the perimeter is just of the rectangle. We have 2 times x plus 2 times x plus 1. So you're basically just using the perimeter formula. You can do x plus x plus x plus 1 plus x plus 1, same thing. 2 times x, so 2x, 2 times x, and then 2. So we have 4x plus 2. Oops, that should be an equal sign. Sorry. And that's all you had to do. This time I gave you the perimeter formula, okay? But you should know if you're referring to a rectangular block or shape, that you should know the perimeter and area formula will probably be involved somewhere. The rectangular section is to be made out of wood. Peter has 8 meters of wood for the 4 sides of the rectangle. Show that the width of the rectangular feature is 1.5. In the stem of the question up here, I refer to it as length, so I'm sorry about that. I hope no one actually realised that, but let's try change that. Okay, so we've got 8 meters of wood, and the perimeter formula was 4x plus 2. So basically we're just solving now for x. So bring 2 over here, and then 6 over 4 equals x, and 6 over 4 is 1.5 meters. Find the area of the rectangular section in meters squared. So your area equals length times width, and we've got 1.5, and your width or your height is just 1 more than that, so it's 2.5. Now if you're ever dealing with this sort of question without your calculator, I always encourage you to do it using fractions. I find fractions a lot easier to multiply than decimals. So 1.5 we know is 3 over 2, and 2.5 we know is 5 over 2. And when we multiply fractions, 3 times 5 is 15, and then 2 times 2 is 4. So that's 3 and 3 remainder. So that's 3.75 meters squared. Okay, let's move on. The arch section is made out of wire and is parabolic in shape. So basically if we go back to the equation here, we're finding this parabola. So it's given us the equation, you just have to find it. So the reason I gave it to you, not so you can do it later on, but basically so you can see whether you got the answer or not. And this question here, even though I've got decimals, it's in turning point form. Okay, you should be able to see it and say, well, that's in turning point form, so I'm going to use the general equation for turning point form. So my turning point, remember the width was 1.5. So like that. So that's half of that is 0.75. And then your height, remember, was 0.72. Oops, 0.75, sorry. 72. So your turning point is 0.75, 0.72. Oh, why do I always do that? Okay, and then we got to find the value of A, so we can just use any point for X and Y. Now, we're just going to assume it's 0, 0, and the other point is 1.50. So we're going to just substitute these values into here. I don't know why I've already got it. Okay, we might use that. So y equals A. If you get confused between your values, just label them. I shouldn't have put y there. 0. A 0 minus 0.75 plus 0.72, and then we're just solving for A. So you could do that on your calculator. Oh, how come I always write 0.5, 0.2? Do that on your calculator, and you probably would have to do it on your calculator because 0.75 squared, you are dealing with fractions or decimals, but I would turn that into a fraction, and then it might get a little bit tricky. So at this stage, we'll just do that on the calculator. So it's just a straightforward solve. 0 equals A times negative 0.75, and that's squared, plus 0.72, comma A. And we just go Control Enter, and then we get negative 1.28. Just get my pen back. Now, what you've done here is enough to show. Okay, I'm quite satisfied with this, and then just writing A. Maybe if you're going into year 12, actually working out this would be probably a bit better, actually expanding it. But at this stage, we'll just leave it like that. So y equals negative 1.28, x minus 0.75 squared plus 0.72. Okay, let's move on. Last question. Question 3. Oh, you know how hard it is to come up with questions? So this one, I wanted a positive parabola, and I was like, what has the shape of a positive parabola? Okay, so a magpie is sitting at the top of a pole, 3 meters above the ground. The magpie spots a cyclist. Magpie swoops the cyclist and returns back to its pole 6 seconds later. So the axis below, blah, 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 sketch the magpie. So sketch the magpie. If you think of it, there's a pole, and here's your magpie. And here's your cyclist. Now the bird, because it's over time, it goes down in height and then goes back up in height. So you're basically starting at 3 meters. The magpie, over time, the height is going down, and then it goes back up to the pole. So this isn't actually representing the bird's flight path, it's measuring its height over time. But I haven't marked your test yet, but I'm pretty sure you would have probably done something like this. So 6, 3, and then this one here is halfway, 1.5. And that's all you really needed to do. Okay, so just a rough sketch, just because I want you to think about the question. Okay, what the parabola might look like. So in methods, you might be given a question that is maybe the very last question. Let's go I don't know, something, maybe get this equation, I don't know, something like that. So you really need to think about what your graph might look like before you go on and answer the questions. Okay, how many seconds after leaving the power pole did the magpie swoop the cyclist? So we did that before, halfway between 0 and 6 seconds, 3 seconds. The magpie's height above ground, I don't know why I left so much space there. The magpie's height above ground over time is represented by the quadratic equation. At what height did the magpie swoop the cyclist? So we know it happened at t equals 3. Not t equals, yeah, t equals 3. So we just have to calculate this. So h equals 2 over, and you could do this straight on your calculator, 3 minus 3 squared plus 1.8. Okay, so this 3 minus 3 is 0, 0 squared is 0, then this times 0 is 0, so we're just left with 1.8. So at what height? 1.8, and it's in meters, so just put meters on. The magpie spots a small dog to swoop. The magpie's height above ground over time can be represented by the parabola below. Okay, so very similar to before. How long does it take the magpie to swoop the dog and return to its pole? Okay, so this time it's taken 10 seconds. Okay, so it started there. There's the dog, back to the pole. At what height does the magpie swoop the dog? So you can see this straight from the graph. Okay, it's at 0.5 meters. And always think about the whether a question or your answer actually makes sense. So if you had a height of a dog of 5 meters, you'd be like, that's a pretty big dog. And the question has stated nowhere that the dog is standing on top of something. So you should probably think, well, maybe my answer is wrong. So always question your answer. So that one, it's 0.5 meters or 50 centimeters. Determine the equation that represents the height of the magpie swooping the dog over time. So you're basically finding the equation of this graph. So I'm going to leave it there so I can refer to it. And, you know, I love turning point forms, so we're going to use that one. Okay, so here's our turning point at 5.5. And we can use either this point here or this point here. I find this point easier because it's got a 0 in it. Okay, so it's 0, 3. This point here is 10, 3. You get the same equation, so it doesn't really matter, but much easier. Okay, so y equals 3, x is 0, h is 5, k is 0.5. If you want to write a half, you can, but I'm just going to keep it with decimals right now. Okay, 5 squared is 25. Bring that 0.5 over, so that's 2.5. So a equals 2.5 divided by 25, which is 1/10. No, is that right? I think so. How come I always doubt myself? 2.5. 25. Yeah. Okay. So we found the value of a. Where are you? So remember, you've always got to substitute it back into your equation. And this one we're using t and h, not x and y. So my equation should really be h equals 1/10 or 0.1 x minus 5 squared plus, and because I use fractions here, I'm going to use fractions here. You can tidy that up if you want to bring it all over the same denominator, but I'll just leave it like that for now. Okay, 1/10. Is that the last question? Okay, cool. And under 25 minutes. Woo! Okay, well done, girls. Bye.